we're going to find the volume of the solid. That is formed by rotating the region. Bounded by y equals x and y equals x squared about the x-axis. So the line y equals x is that diagonal line, and a parabola would look like that. So here's what our region would look like. Now, to be able to see that that's what the region looks like, you would really have to zoom in on your calculator, because this is happening from 0 to 1. The point where they intersect is 1, 1 right there. So they intersect at 0, 0, they intersect at 1, 1. And we're going to reflect this or rotate this around the x-axis. Oh, this is going to be hard. Okay, so this point, if you can see it, like spins around and ends up over here. And that point would stay stationary. And I'm going to go ahead and kind of draw this. So there's kind of the straight side, there's the curved side, and if you can picture that thing spinning, this would be like a cone that is not really filled in, if you can picture that. Like a funnel almost is kind of what that would look like. So just picture this kind of like this is spinning around right here. So the outside of the shape would kind of be similar to this. But it wouldn't be solid like this. When we spun it, since that whole thing was shaded, then when we spun it, it made a solid, a complete solid. Here, when you spin it, the inside is going to be hollow. And so here, what we talk about for this as far as the cross section is we call it a washer. So if you were to take a little slice of that, the outside of that would be a circle, so this outside edge spinning around would make a circle, but this inside edge would make a circle as well, so it would be hollow in the center, so it looks like a little washer. Or you could call it the donut method if you want. Right? Reminds me of donuts as well. Okay. So with the washer method, again, our cross-section is circular, but to find the area of this part, we have to take the area of the larger circle and subtract the smaller circle from it. So what we're going to write for our, so this is our cross-section, is a washer or a donut. And then our area formula is going to be pi r squared minus pi r squared, where the big R is the radius of the big circle and the little r is the radius of the little circle. All right, so for you to find the r value or the radius of the big circle, we had two different equations. We had y equals x and we had y equals x squared. So if you can see it, the y equals x line, the top line, is the one that's rotating on the outside. And it's so the radius is the y coordinate, and the y coordinate you get by what you plug in here. So that means that the radius of the big circle is whatever I plug in for x, because that's what gives me the y value. The radius of the little circle, if you can see, is the inside part right here, and that comes from the parabola. And so the radius, again, is a y coordinate, and I get it from whatever I end up plugging in right here. So the little r is going to be x squared. So if we want to find the volume of this shape, we're going to go from 0 to 1, because those are the x values we have, from 0 to 1, and we're going to do the big circle minus the little circle. So I'm going to say pi times r squared minus pi times r squared dx. And if you plug that into your calculator to evaluate it, you get 0.419. And again, we're finding volume, so units cubed. Alright, in our last example for the video, we're going to find the volume of the solid So we're actually doing a similar problem to what we just did. We're going to rotate the region bounded by y equals x and y equals x squared. So it's going to be that same little piece that we had before. But this time we're going to rotate it about the line y equals 2. So I've got that same line that I had before. I've got that same parabola that I had before, and I've got this same shape. It's straight on this side and curved on this side. And this time, we are rotating it about the line y equals 2. So if I rotate it around the line, and that point ends up there, this one, when I rotate it around the line, it's going to end right here. And then our straight side is going to be on the inside, and that curved part is going to be there. And then if you can picture it, we're rotating the whole thing around, so even though I didn't fill this in, that's what it would be. This would be kind of like a bowl shape with the whole, like with the bottom cut out, if you can picture that. So it'd be like, I don't know, literally the shape would be like this, kind of, if you guys can picture that. So if we look here, again, we're talking about a washer, so I'm going to say the cross section is a washer, and so that means that we are going to be doing pi r squared minus pi r squared. And the radius of the bigger circle is going to be from this edge, which you can see is from x squared, to this line right here. And so to find the distance between those, we're going to say top minus bottom to find the big radius. So top minus bottom. And then the smaller radius would come from that straight line. So we're going to do, again, top minus bottom. And then we can go ahead and write our integral. So we're still going from 0 to 1 because we still have, this is still our shaded region. So from 0 to 1, and then we've got pi r squared minus pi r squared and that's going to be 1.676 units cubed. So quite a bit bigger than the other shape, because we're making this big kind of bowl shape, and that was like a little itty-bitty funnel shape. All right, so we're going to do like a little summary. We'll do more of a summary in class just to kind of bring this all together and do some more examples. But a couple things to summarize is that for a disc shape, you're going to see that your area is just a circle, cross-section is just pi r squared, and you're going to notice that the whole shaded region touches the axis of rotation. So whole shaded region touches axis of rotation. With the washer method, our cross-section is going to be a washer. And you're going to notice that there's going to be some space. There's going to be like gaps. So this is not a solid sort of object. It's hollow on the inside. So we're going to say there's going to be some white space between the region and the axis of rotation. And then we'll go a little bit more in depth with that tomorrow.